Okay, so in this class we're going to be talking about significant figures. So this is in section 3.4 in the textbook, and it starts at the bottom of page 39, and most of the content is over on page 40. So I'll give you a minute to pull out your textbooks and open up to that section. All right, so is everybody open to that section 3.4? All right, so you may have heard of this topic of significant figures in previous science classes, probably, maybe in high school. So you may or may not remember what that was about. But we're going to cover this, and there will be times, not all the time, but there will be times when we'll use this concept of significant figures. All right, so in a minute we'll talk about what the significant figures means and why we're going to apply it. But first off, let's talk about in what case we're going to apply significant figures. All right, the first thing I want to talk about is what types of numbers use the concept of significant figures. Okay, so we're going to talk about, I didn't spell that right. First thing we'll mention is two different types of quantities. One is called an exact quantity, and the way we achieve an exact quantity is by counting. For example, we can count the number of people that are in this room and we can get an exact quantity. We can count the number of chairs in this room and we can get an exact quantity. We can go out in the parking lot and we can count all the cars in the parking lot, and as long as we're careful, we can get an exact quantity. So we are not going to be applying significant figures to exact quantities. Significant figures are actually applied to something called an approximate quantity. Approximate quantities are not achieved by counting, they come from measurement. So you achieve an approximate quantity by measuring. That could be length, time, weight, any kind of physical measurements. So all physical measurements are assumed to be approximate. With the last digit having been estimated in some way. You never know what the true measurement is. You can approximate it and get pretty close. But so physical measurements are approximate because the last digit is estimated. So we'll apply significant figures to approximate quantities. And we will be doing in this class and in upcoming classes over the next year a lot of measurement. Okay, so what are significant figures and why do we need to apply this concept to measurements? Let's look at an example. Let's illustrate this with an example just so you can see why this is an important concept. So let's say you're on the job and you are given a task. And your task you're given the task to measure the flow rate in a pipe. And you measure this by collecting this liquid, whatever it is in the pipe, collecting it in some kind of container that's graduated so you can measure the volume. And then at the same time you have a stopwatch, so you're recording how much time it takes to collect a certain volume of this liquid. So here are the measurements you collect. So you collect 5.25 gallons, and let's say it takes you, and then you have a stopwatch that goes out to 2 decimal places, and let's say it takes 12.13 seconds. So in order to calculate the flow rate in gallons per second, then you divide the 5.25 gallons by 12.13 seconds. So go ahead and pull out your calculators and actually do that. See what result your calculator gives you. All right, so did you get a calculation, and what is your calculator telling you? All right, so let me try that again to make sure I get the right answer here. All right, so here's what my calculator's showing. Now, every calculator might not be the same. Mine is displaying 9 decimal places. Yours might be 8 or 10 or something else, depending on your model. So I'm getting 0.432811212, and that has units of gallons per second. All right, so what's your reaction to that? Okay, here are your measurements. That's your result. So let's say you were given a task of measuring this flow rate and other flow rates, and then you typed up a report, and then you submitted your report, and then people read your report. And let's say what you were reporting was the flow rate. And let's suppose that the people reading your report did not also see the raw data or the measurements you used. So all they were seeing was this result, but not the measurements. What kind of impression might somebody get when they see that result? Well, if I was looking at that result, what I would think is you were using some pretty high-end, expensive measuring equipment to be able to get a result that accurate, out to 9 decimal places. That's highly accurate. So the problem with this result is that the answer is not consistent with the accuracy of the measurements that you took. So this is really the basis of the concept of significant figures, to make sure you're not reporting a result which appears to be much more accurate than the actual measurements that you took. Now, we're not going to actually correct this now and express the answer properly because we haven't talked about the significant figure rule yet. But we'll come back to this example here in a few minutes once we've talked more about the significant figure rule. So now let's hop over to page 40. The first thing we'll do is let's first discuss the actual rule of significant figures, and then the next task after that will be to figure out how do we define what a significant figure itself is. So you'll notice on page 40 that there are two rules listed. In the middle of page 40, there's a rule number 1, which is what we'll use. And at the bottom of page 40, there's a rule number 2, which we will not use. Rule number 2 is rather obscure, and it's also confusing. It ends up confusing more than it helps, and you would rarely ever use it anyway. So we're only going to use rule number 1. So this rule is not only going to tell you how to apply significant figures, but also tells you in what situation you actually apply the rule. So when approximate numbers, and remember those are measurements, are multiplied or divided in some kind of a calculation, then the answer has the same number of significant figures as the least accurate The answer has the same number of significant figures as the least accurate of the factors, a math term, or the actual measurements that we're using in the calculation. All right, so that is the rule. Again, that's rule 1 from page 40. But in order to really apply this properly, we have to then figure out how is a significant figure defined so that we can apply the rule. Okay, so now what we're going to do now, there is a bit of a discussion of this in the top half of page 40. There's a discussion that tries to define significant figures. It's okay, you can use this, but there may be a better discussion of these guidelines in your workbook. So if you could, pull out your workbook, and we're on page 6. right, so is everybody on page 6 in the workbook? All right, so there are 5 guidelines that help you determine for a given number, or in our case a given measurement, how many of these digits that you're seeing are actually significant. Okay, so let's go through these examples. Okay, so the first one tells you that if there are any zeros at the beginning of a number, they are not significant. So in this case, is 0.75, the 0 is not, 0.037, the zeros are not. But that also means that everything else is. So if you look at 0.75, there are 2 significant figures. The 7 and the 5 are both significant. So I'm just going to jot a little 2 there. All right, and then for the number 0.037, the zeros are not, because zeros at the beginning are not significant, but the 3 and the 7 are. So 0.037 has 2 significant figures. All right, number 2, zeros that are buried within a number, in other words, not at the beginning or not at the end, are significant. So for 3.08, all of those numbers are significant, and 9.204, all of those numbers are significant. So 3.08 has 3 significant figures, 9.204 has 4 significant figures. And once again, we need these guidelines in order to properly apply the rule of significant figures, and we'll get back to that in a minute. All right, number 3, zeros at the end of a number, but also after the decimal point, are significant. So 24.70, all the numbers plus the 0 are significant. 1.360, the same case. They're all significant. So 24.70 has 4 significant figures. 1.360 also has 4 significant figures. All right, next one. Number 4. Zeros that are at the end of a number but before the decimal place are not, before the decimal point, are not significant, unless the person who collected the data tells you otherwise. So the assumption here is, let's look at the first one, 3,700. So the assumption here is, unless you're told otherwise, the 7 was the estimated digit and the 2 zeros are not. And then 24,500, the assumption is the 6 is the estimated digit and the 0 is not. So 3,700 would have 2 significant figures, and 24,560 would have 4. All right. Now, number 5 is a little bit of a summary. Number 5, as you see, is kind of a summary of items 1 and 4. 1 and 4. Zeros at the beginning and zeros at the end. So the summary is, and this statement's also in your textbook on page 40, zeros which are only there to identify the location of the decimal point are not significant. So what does that mean? Let's go back to number 1. What we're assuming here is that the 0 at the beginning of 0.75 and the 0.0 at the beginning of 0.037 are really just there to help you identify the location of the decimal point. But they did not really enter into the measurement itself. They're not considered significant. Then let's go down to the number 4. The assumption here is that the 2 zeros at the end of 3,700 are only there to help you identify where the decimal point is after the second 0. And the same thing for 24,560, that the zeros actually weren't part of the measurement, but they're needed in order to tell you where the decimal point is. Okay. You'll get better at this as you apply it and we work through some problems. All right, so those are the guidelines. Now this page will always be available to you in your workbook, so you can always go back at any time and refresh yourself on these guidelines for identifying significant figures. All right, so now that we've talked about the rule of significant figures and we know how to identify significant figures, now let's go back to the flow rate example. So we collected data, 5.25 gallons in 12.13 seconds. And when we did the calculation, this is what our calculator reported. All right, so here's how you would do this kind of a problem to express your answer to the correct number of significant figures. First, you look at the measurements you're using in the calculation. How many significant figures are in 5.25? 3. How many significant figures are in 12.13? 4. And rule number 1 says, when approximate numbers are multiplied or divided, in this case divided, the answer has the same number of significant figures as the least accurate of the factors. What does that mean? The least accurate of the factors is whichever one has the fewest significant figures. So the fewest significant figures in these measurements is this one, 3, which means you express your answer to 3 significant figures. That's how you make the decision. All right, now that you've made the decision, what do? How do you express this answer to 3 significant figures? So 3 significant figures will be, so the 0 at the beginning we've already talked about is not significant, so it'll be 3. So this will be the last place in your answer. So what do? You used your rounding rules from math, the same rounding rules you've learned in all of your math classes. So what you don't do is you don't decide, okay, I need 3 significant figures and everything else gets dropped. You don't just drop everything that you don't want. You actually have to round using your rounding rules. So you're going to be rounding the 2. You look to the right, that's 5 or greater. So you're rounding this digit up. So the correct expression for this answer is 0.433. Your answer has 3 significant figures. So this rule makes sure that you're not expressing your answer to a greater accuracy than you achieved in your measurements. All right, let's do another practice problem here. Let's say you were given the job of determining the floor area in some room and you were measuring it in metric. Here's your measurements. So you measured one dimension at 5.70 meters, another dimension at 4.32 meters, and you need to determine the floor area. So this is area is length times width. You're just multiplying these two together. So what is the proper way to express that answer to the correct number of significant figures? So go ahead and take a minute to do that. So let's first write down everything that your calculator displayed. Don't forget your units. Units behave just like numbers, so meters times meters is square meters. So this is the result your calculator reports. What's the proper way to express that answer? How many significant figures are in 5.70? 3. How about in 4.32? 3. So you're going to apply your rounding rules. We're going to express 3 significant figures in your answer. So you're using your rounding rules. So your answer is 24.6 square meters. Now this might look a little bit odd to you. What's odd about it? Well, each of the measurements was expressed in 2 decimal places, but your answer only has 1 decimal place. It may look a little odd, but the reason is because significant figure rule is not about decimal places, it's about significant figures. So you haven't, so far in this section of the text, heard references to decimal places. It's all about significant figures. So this is the proper way to express the answer. And let's do one last example here. Here's another example. Let's assume these are measurements. I don't have units for you for this one. This is more just a mathematical example. So let's say you had these 2 measurements and you were dividing them. What's the proper way to express that answer? Alright, so here is the answer reported by the calculator. So each of these numbers has 3 significant figures, so we want to express the answer to 3 significant figures. So we're going to be rounding the 3rd number over. And are you rounding up or down? Rounding up. So your answer is 1.60. The 9 gets rounded up. In this kind of a problem, make sure you don't just drop the 0. The 0 is significant, and it'd be proper to, the only way you can express 3 significant figures is 1.60. Alright, so let's wrap up this topic. Alright, so remember that you achieve the correct number of significant figures by rounding. Another thing I want to point out to you in the text, so if you could go back into the textbook, top of page 41. There's something I want to point out to kind of clear up some questions you'll have during the term. Alright, so at the top of page 41, the author declares that throughout the book, whether it's example problems in a chapter or end of chapter problems, he's also going to assume that all given data in a problem is accurate to 3 significant figures, and therefore all of the example problems and end of chapter problems will have answers expressed in 3 significant figures. There'll be times where you'll wonder why. Well, he's just declaring at the beginning here that that's the practice he's going to follow. Okay. Another note, in our first lab next week, the measurement lab, you'll be performing calculations on measurements that you take, and you'll need to express your answer to the proper number of significant figures. But you can always go back into the text or the workbook and refer back to your notes if you have questions on how to go about that. All right, so now you're ready for one of the worksheets. In the workbook, let's now go to pages 9 and 10 in the workbook. All right, so here's, now you may have a question about grading. Are these worksheets graded? No. It'll be very clear to you when there's a worksheet that you're going to turn in as graded homework. The worksheets that are in the workbook are all for practice. So in this worksheet, there are 3 sections. One, the first section on page 9 is practice with metric units and prefixes. The bottom half of the page is practice on scientific notation. I'm not sure if we've discussed that yet, but I think you've been exposed to that in the past. And then more significantly, based on today's class, is page 10 has 4 problems for you to practice the application of significant figures. You can check your results. In most cases, the worksheets in the workbook have answers in the back. So there's a tab in the very back, and so you can, after you do these problems, you can look to see how well you did back in the answer section. So if you could, you can get started on those now, worksheet number 1, and then next class we can discuss any of those problems. All right, I think that's it.